Okay, now we are on page 6 out of 10. So hopefully it'll go quicker than I think it will. But, anyways, end behavior is determined by the leading term and its coefficient. Leading term is the term with the highest degree. Leading term is the term with the highest degree. Its coefficient is the number in front of it. I've been talking about coefficient off and on just a tiny bit, and I've been talking about degree, so a little bit. So I've kind of been introducing you to some of this off and on as we've gone. But now we're really going to get into this. So if your highest degree is 1, 3, 5, 7, or in other words, your exponent is odd, okay? Or if it's even, it'll be 2, 4, 6, 8, blah, blah, blah. Now, how does this work? Well, I'm going to split this into 4 pieces. Even, and odd, and each one of these I'm going to split into positive and negative. Okay? So, if you have a positive leading coefficient, then I'm only worried about the end behavior. Okay? I don't care about the middle. So I kind of yucked up the middle. The middle could be a smooth curve. It could be a dumpy curve. It could be a lumpy curve. I don't know. That's why I've yucked up the middle. We don't know what happens in the middle. It depends on what that number is and what these pieces are. So, what the big fat hairy deal is this. Both of these endpoints go the same direction and they both go up. Now, if the leading coefficient is negative, then both of these go in the same direction and they both go down. Well, let's say that it's odd. If the leading coefficient is positive, then the left goes to the bottom and the right goes to the top. And again, the middle could be lumpy or it could be smooth. Then if the leading coefficient is negative, then it could go the other direction. And again, we don't know what the middle does. It depends on what the numbers are. But notice one goes one direction and the other goes the other direction. Now, when this happens, all right, both of these are in the positive infinity direction. When you have a positive coefficient and a negative infinity when you have a negative coefficient. Now, when your positive coefficient with an odd degree, this is negative infinity and positive infinity. Then when you've got a negative coefficient, that's positive infinity here and negative infinity here. Whew! Now, example 1. All you really have to do is type in this. I don't have to type in this to know what happens. All I have to do is look at the leading term to know what is going to happen. So, 6x to the 4th. So, notice if I add stuff, negative 7x to the 3rd, it made the shape change, but the end behavior did not change. See? Still goes up to the left and up to the right. Well, let's say I had to put a square there. Made the middle look different, but the ends are still the same. Now, number next, and I'm not going to go back yet. Number next, negative x to the 5th. Up to the left, down to the right. Okay, up to the left, down to the right. So select the graph that represents the following. So just type this into either Mr. Goodbuddy or Desmos, and then pick the graph that matches it. Oh, by the way, let's go back real quick. Okay. Oops, that's what I wanted. 6x to the 4th, positive and even. Positive A and even. I don't even have to use Desmos or graph it. I know that this is what happened. Now, odd and negative a. So this is what happens. Now, I had a brain fart when I was typing this one up. I'm just going to tell you. Type this into Desmos, okay? And I'm not going to go to Desmos on this. I'm just going to negative 2x. Oh, whoops, that's positive. Okay, I used Desmos to graph it with, just so that I could get my points. This is positive A and negative. Or not negative, positive A and odd. But because I graphed it using Desmos, I have my values. Okay. Find the x-intercepts as coordinates separated by commas. -1, 0, 0, 0, 1, 0. Then it says, what is your y-intercept? Well, that's nice, because it also happens to be an x-intercept, where it crosses the y-axis at. Now, find the values where it is positive. This is one of the things that tends to confuse people the most. Okay. Okay. The x-axis equals 0. Above the x-axis is bigger than 0. Below the x-axis is smaller than 0. Here's where it's smaller than 0, or another way of saying smaller than 0 is where is to say negative. Another way of saying bigger than 0 is to say positive. you are only going to use parentheses for negative and positive. You're not going to ever use a bracket here. All right? Now, it is positive here and here. Now remember, the arrows tell us where it's going. Not only is this going up, it's also going to the right. Right is positive infinity. So not only is this going down, it's going to the left. Left is negative infinity. We always use the x value. All right? So always use the x values to describe the positive and negative intervals. Now, since I already have my black highlighted, let's choose negative. So always go from small to big. Small to big. So it starts at negative infinity. And it stops at -1. But it can only be happy if you put its other piece, because there is another piece. And that starts at 0 and stops at +1. Now we have to put the positive pieces. And there's 2 of those as well. So the positives, it starts at 1 and stops at 0. Starts at -1, stops at 0. Then it starts at 1 and it stops at infinity. Now, I want to put this one into Desmos for you to see. Okay? Negative. And there's 3 of these. Ah! Hang on just a minute. I don't think that square goes there. I think it goes here. X squared minus 25